Good day, good day. I mentioned already that this quiz I'm not going to actually be counting. This is purely for your own edification, but I'm saying that for people who are at home and panicking. All right. Oh, my favorite student. No, Parker, it's not you. Good old Anne. She gets everything right. All right, number one, we've been talking a lot about acceleration. What is acceleration? I'll take probably a fair range of answers, and I'm not going to ask you to define a question on a test, but we should understand what we're talking about. What's acceleration? Aiden, what did you say? Rate of change of velocity is the textbook definition, and if you said that, by the way, for 2 marks, probably 1 mark for the definition. Is acceleration a vector? Does direction matter? Yeah, so 1 mark for saying yes or why. If you said rate of change of velocity, I would take that. If you said this, that's the mathematical way to write the rate of change of velocity, because delta V is the change in velocity and rate is dividing by time. Ooh, if you said this, I would say, oh, that's a complete mathematical definition, and that's absolutely valid. Did anybody say anything else? Try me out, and I'll be generous. Yeah. Yep. Totally take that. Anybody else? All right. Number 2, there's going to be 5 or 6 multiple choice-ish questions on your test. I'll even be more blatant. In one of them, I think the last one, I think that's the only one where you're having to do some calculations. I ask you to calculate the G's on something. How do you figure? Well, wait a minute. It's going to be later on in the quiz. Spoiler alert. I think on the last question, I asked you to find how many G's. So how do you do multiple choice? If you haven't gotten in the habit of crossing out answers that you know are wrong, it's probably a good habit. So it says this: an accelerating body must at all times circle the best answer. True or false? A, an accelerating body must have positive velocity. Can you be accelerating and still have a negative velocity? Give me an example. First of all, what would I mean by negative velocity? My go-to is usually in reverse on a car, backwards. So can I be going backwards and be accelerating? Now remember, it doesn't mean braking or going forwards. All it means is changing my velocity. Can I be going backwards and slowing down or speeding up? Well then, that's not true. I don't always have to have that. What about B? Can I accelerate and be slowing down? Yeah, because we said acceleration doesn't mean speeding up. It just means changing your velocity. Changing your velocity. So that's not correct. Can I be accelerating and going in a straight line? Then that can't be correct. Right? Because it's saying you must have at all times these ones. So I looked, Jaden, at the opposite. I said, well, why don't I see if it's possible to do it the other way? Then this answer can't be correct. Jaden, what's the correct answer? Yep. Because that's the definition of acceleration. Say whether your velocity is increasing or decreasing in each of the following situations. I'm going to abbreviate. My abbreviation for increasing is an arrow pointing up. Can you guess what my abbreviation for decreasing is? An arrow pointing left. Down! That's way, you know what? Yeah, let's use that. Down. That's way better. Left, that was a dumb one. Okay. So, velocity is positive. I'm thinking forwards. And acceleration is positive. So we're accelerating forwards. What's happening to our velocity? Is it increasing or decreasing in A? Increasing? I think so. That would be like being in a car and stepping on the gas. Yeah? Okay. B, my velocity is positive. I'm going forwards. And my acceleration is negative. What's happening to my velocity? Increasing or decreasing then? Give me an example of how I can have in a car a forward velocity but a negative acceleration. But that's stepping on the brakes. Okay? Now it gets a bit trickier because C, velocity is negative. I'm in reverse. And my acceleration is positive. I'm accelerating forwards. What would that be doing in a car, by the way? If you're in reverse, but you're accelerating forwards, what's happening? Here's my question. You're in reverse. If you're accelerating forwards, are you stepping on the gas or stepping on the brakes? So if you step on the gas, when you're in reverse, you're saying that accelerates you forwards. What are you stepping on? This is stepping on the brakes in reverse. Okay? You're going backwards, but your acceleration is in the forwards direction. What's going to happen to your velocity? You're in reverse and you step on the brakes. What's going to happen to your velocity? Sorry? Okay. Can you think of a way that you could answer that and say it was increasing? That's your cue. Because you said, Mr. Dewick, C can be both, and I will give you a mark for increasing, but you have to convince me. Come on, this is your chance for a candy and glory.
I honestly put increasing because the acceleration is positive. So
Okay. Keep going. Yep. Okay. So let's make up some numbers. Let's suppose we're going negative 10 meters per second. If I step on the brakes, positive acceleration, now my speed is negative 9. Yes? Negative 7. Hey, is negative 7 a bigger number or a smaller number than negative 10? Technically, negative 7 is a larger number than negative 10. It's a smaller magnitude if we take the absolute value, if we ignore the sign. But negative 7 on the number line is to the right of negative 10. So if you thought, well, you know what? We're talking negatives here. Actually, your velocity is increasing because the negative numbers are getting closer to 0, and those numbers are bigger. If you thought that, I would give you full credit. I would never let this question go on a test because it's too vague. Okay, so this won't be on your test. In fact, number 2 as a question won't be on your test either. So I would take increasing if you thought that. And D, velocity is negative. You're in reverse. Acceleration is negative. What pedal are you stepping on if you're in reverse and you're accelerating in the negative direction? You're stepping on the gas. And so you could say that your velocity is increasing, but again, you're going from negative 10 to negative 11 to negative 12 to negative 13. If you're a math nerd, I am, you could say, Mr. Dewick, negative 13 is smaller than negative 10. And so I would accept if you argued with me and said, no, it's decreasing. And my little math nerd heart would say, technically, you're correct. What I should have said was, because all speed cares about is the magnitude, not the direction. It doesn't care about the negative positive. What happened to number 4? I don't know. 5 is a good question. 5 is totally fair game for your test. So it wants the acceleration. I'm going to say A equals VF minus VI over T. I'm going to cut corners a little bit here, Liam. I'm going to go straight to the equation and the numbers because I want to get this marked as fast as possible. But as usual, half mark if you wrote VF equals VI plus AT, half mark for writing that equation, half mark for the numbers, half mark for the answer. I noticed that the speed is decreasing. I'm going to get a negative acceleration. I could do this in my, not negative 20, Mr. Dewick, negative 25. I can do this in my head, though. It's going to be negative 20 over negative, or over 8 is going to be 10 over 4 is going to be 5 over 2. Negative 2.5 meters per second squared. Okay. Ronan, I said earlier, and for those who got here a bit later, I'm not actually collecting this quiz for marks because some of these questions I deliberately made vague and challenging and not clear enough for me to be acceptable on a test, but this is good thinking questions. 6 would be fair game on a test. Average acceleration while the bus is braking. Let's see. You know what? This is the same question as number 5. The only difference is stops, so V final is 0. Negative 5? If you didn't put the point 0, I'm not going to freak out. I just have a habit of going to 2 or 3 sig figs always. I would be fussy on the negative, though. Half mark off if you don't have the negative. Looks like number 7 wants me to find V final. I think I'm going to use VF squared. No, Mr. Dewick, hang on. I'm going to use VF equals VI plus AT. It's going to be 103 plus, slows down, negative 5 times 7.5. There will be a question on the test where I give you a slows down acceleration. I might be nice and put the negative in front of the 5 to jog your memory and let you know that it's negative. I might be mean and say you better spot that it needs to be negative because I underlined the words slows down. I don't know yet. I'm going to photocopy the test tomorrow. (103 minus, well, plus negative 5 times 7.5. You get 65.5 units. It's a velocity, meters per second. Okay. How long? You know what? This is asking me to find a time, I think. So it's going to be T equals VF minus VI over A. It's going to be 10 minus 2 over 3.5. Oh, this is going to be yucky. What was that? Question? No? Do you get 2.29? If you said 2.28, I would take a half mark off. I'd live with 2.3, but let's go in the habit of going to 3 sig figs. Units, seconds. What must your initial... Oh, now it wants me to find VI. Well, the equation I started out with is VF equals VI plus AT. How would I get the VI by itself? Well, the VF is going to drop down like a domino. Although I can't drop down, I had to move sideways, but... How would you get the VI by itself? Liam, how'd you get the VI by itself for number 9? Yeah. Minus the AT over. Totally agree. So it's going to be 20 minus 3.2 times 3.3. You'll get 9.44 units meters per second. How many marks is number 10 worth? Okay, somewhere on your test, I'm going to give you a question where you have to find something in order to find something. This is an example. So it says, how fast is it traveling? I want to find VF. Time is 7.5. It started out at rest. Sarah, what else would I need if I wanted to find VF? I think I would like to find A. Typically in my notation, if I have to find something in order to find something, I put a question mark next to the thing that I'm trying to find, and I put a blank next to the blank I need to fill in order to find what I'm trying to find. That's my high-tech, being organized but lazy system. Whatever works for you, Brayton, I'm fine with that. So I went, okay, I guess I'm going to go A equals. We're starting at rest, and it told me that after 12 seconds, I'm traveling 30 meters per second. I can find A from that. A is going to be VF minus VI over T. It's going to be 30 minus 0 over 12. I can do that in my head. 30 divided by 12 is going to be the same as 15 divided by 6 is going to be the same as 5 divided by 3. Is that 1.6 repeating? Am I wrong? I might be wrong. I think I'm wrong, Mr. Duick. 2.5. Duick, way off. If you found that, if I saw that somewhere, that would get you 1 mark. And now, 1 mark for that. 7.5, well, 2.5 times 7.5. Not that it makes a difference when you're multiplying. Final answer, you get 18.8. If you wrote 18.75, I'm okay with that. And then what I would probably do, because I've done a bunch of work all over the place, I would probably put a box around the answer to make it easier for the marker to spot what I've done, but because I kind of wandered all over the place. Is that okay? So then 1 mark for that, 1 mark for the answer, 1 mark for finding A. I wouldn't let number 11 get on the test because you have to assume that we're dropping it. 11 would be fair game if I said, suppose we drop an object from a cliff. what is the velocity. So if I included the word dropped to let you know, then it would get on the test. So it looks like each of these wants me to find VF. I think for all of these, VF is just going to be AT, because VI is 0. So for the first, I can do this in my head. It's going to be negative 19.6 meters per second, yes? And the second one is going to be negative, let's see, 6 times 10 is 60, 58.8? 2 marks each. So I would, I guess, give you 1 mark for that, 1 mark for the answer, 1 mark for the equation, 1 mark for the answer. So 2 marks each. Number 12, also, we have to assume dropped. I would live with number 12 on your test if I said, suppose we drop an object from a cliff. How long does it take? Anyways, it wants me to find time. I think time is going to be VF minus VI over A. Wait a minute, what was VI if we dropped it? So actually, it's just going to be VF divided by A. So it's going to be negative 24.5 divided by negative 9.8. Did you get 2.5 seconds for the first one? And again, 2 marks for that. 1 mark for the equation, 1 mark for the answer. Negative 63.7 divided by negative 9.8. 6.5 seconds. Number 13, it's asking me to find D. Again, I wouldn't let number 13 go on a test without including the phrase, suppose we drop an object from a cliff, or an object is dropped from a cliff. We have to assume VI is 0. But if we do that, for all of these, it's just going to be AT squared, because the VIT vanishes. So it's going to be negative 9.8 times 2 squared. It's going to be 19.6 plus 2 is going to be 39.2? Negative 39.2? Am I wrong? Looks like people looking at me, I'm wrong. Oh, I forgot the half. Mr. Dewick, what happened to the 1/2? How are you doing that, Mr. Dewick? So it's not negative 19.6. Wow. Dewick, that was terrible. That's a mistake. Don't do that what I just did on a test. This is why on a test or a quiz, you show your steps more meticulously than what I'm doing. I'm doing this like I'd be trying to do the homework, which is not good. So it's, again, going to be D equals 0.5 negative 9.8 times 6 squared. 0.5 times negative 9.8 times 6 squared. You get negative 176.4. I'll call it negative 176. Because this question didn't say if I had said find the displacement, I'd be insistent on the negative. Because this didn't use the magic vector word displacement, meh. However, in number 14, I am going to have to make the 533 negative because my equation expects a displacement. How long? This is, I like 14a. I like 14a. 14a is a nice question. This is where we have to go D equals AT squared over 2. VI is 0, because it did say dropped. How do we get the T by itself? I guarantee on your test, I will ask you to get this equation, T by itself. Or you could write it as D equals 0.5 AT squared. I don't care. No matter what, you're either going to get times by 2 divide by A square root, or you're going to get D divided by 0.5A square root, because dividing by 0.5 and timesing by 2 on the top are the same thing. It's going to be negative 2 times negative 533 divided by negative 9.8. Oh, square root. I was going to say, that's a long free fall. 10.4 seconds. Has anybody been to the top of the CN Tower? You have? Did you do the walk around outside? So they do, you can, it costs money, but they can tether you and you can do a walk around outside. And I just saw now they have an activity where they tie the tether to your back and they drop you falling forwards and yank you to a stop when you're parallel to the earth. I think I could psych myself up to do that, but I don't know. How fast? Oh, now it wants me to find VF. Well, I guess I would go VF squared equals 2AD. Although, you know what? I'm quickly going to do a check. I also know that VF equals VI plus AT. I'm going to multiply this by negative 9.8, and I'm going to say I should get that. Now let's try doing it this way. It's going to be square root. So it's going to be the square root of 2 times negative 9.8 times negative 533.3. Good morning, sir.
Good morning.
Square root. How come I got positive 102.238 blah, blah, blah? How come I didn't get negative? Yeah. Well, your calculator always assumes you want the positive square root. In this case, I know I want the negative square root. I like B. I guarantee, Jaden, on your test, I will give you one where the only way to find velocity is to use this equation. If you're on your way up, it's positive, but I'm pretty sure I stuck one on there where you are on your way down, and you'll have to say, thank you very much. I know the answer that I want is negative. Ooh, 15. This was your curveball. How many times farther does a freely falling object fall in 10 seconds than in 1 second? First, we got to figure out how we're going to do this. How are we going to do this? Nick, let's suppose you have $10. I have $50. How many times more do I have than you? Sorry? Okay, try and move it a little quieter. Thank you. 5. What did you do with a 50 and a 10 to get a 5? So one of the interesting things is if I ask how many times farther, you're actually dividing, not timesing. So here's what I think I'm going to do. I'm going to find the distance I fall in 10 seconds. I'm going to call that D10. I'm going to find the distance I fall in 1 second. I'll call that D1. And then my answer is going to be D10 divided by D1. In the same way, you have $10, I got $50. How many times more do I have? Bigger divided by small. I think it's going to be AT squared. Again, we have to assume dropped. So it's going to be negative 9.8 times 10. I forgot the half again. What am I doing here, Mr. Dewick? It's a half AT squared. This is weird. I've never done this before. I wish I was doing it on purpose to see if you're paying attention, but I'm not. And I think if I do this one in my head, you get negative 490. Yes? 10 squared is 100. Half of 9.8 is negative 4.9. Here, it's going to be negative 0.5 times, sorry, not negative, Mr. Dewick. 0.5 times negative 9.8 times 1 squared. And I think you get negative 4.9. Is that right? And I think if you go negative 490 divided by negative 4.9, 100 times further. I'll use X as my abbreviation for times because it's a time sign. If you got that, 3 out of 3. Otherwise, I would give you 1 mark if you found that, 1 mark for that, and then 1 mark for being clever and realizing, even though it says how many times, I divide. Number 16 is interesting because it says down slope. You could let down be negative and up be positive. It's a slope. We're not in free fall. So you could also say, I'll let down the hill be forwards, which is positive, and up the hill be backwards, which is negative. So I'll take both a positive or a negative answer for this. I'm going to let going forwards be positive. And so I'm going to say that VF equals VI plus AT, but it says slips its brakes, so VI was 0. It's going to be 1.1 times 6.5. 8.16? No. 8.15? No, okay. 7.15, not 8, Mr. Dewick. Carry a 1. How far? I think I would use D equals a half AT squared. Jeez, I don't know why I'm forgetting that. 0.5 times 1.1 times 6.5 squared. You get 23.2. And again, for both of those, I would accept a negative if you chose to let down the hill be negative, because then that acceleration would be in the negative direction because it's down the hill. And I would accept that as a negative because if you chose to let down the hill be negative. I figured call it forwards. Looks like they want me to find time. Ooh. Marley, how many marks is 17 worth? I'll bet you I'm going to have to find something in order to find something. So I started out going like this. I went VF minus VI over A, and I said, wait a minute, I don't know A. Maybe I can find A, I said to myself. So over here, I said, okay, I think I can go VF minus VI over T, because it said we're at 9.9, starting from rest, 1.8. This is the same as 99 divided by 18, which is the same as 11 divided by 2. 5.5? No? Yes? And now I can walk over here and I can go 16 minus 0 divided by 5.5. Is 5.5 right? Yeah? What's your question?
Doesn't matter.
I only look for units on your final answer. Okay, good question. He said, if I didn't put the meters per second squared on something I found partway through, I'm not going to freak out about that. Okay, 2.91, if you said 2.90, I would take a half mark off. 2.91 seconds. Is that correct? Okay. Wants the acceleration. I think I'm going to go A equals VF minus VI over T, 48 minus 0 over 12. Oh, this I can do in my head. 4, yes? Yep. And then B, how fast is the plane moving after 16 seconds? I have to use my answer from A. There's no way to find V final without that. So it is going to be VF equals VI plus AT. Wait a minute, VI was 0. I didn't even need to write that. But it's going to be 4 times 16, 64 meters per second. So this will be an example of, and I did tell you, there will be at least one question somewhere where I'm going to make you use an answer to find an answer. Okay? How far down? I guess I'm going to use D equals a half AT squared. Again, I'm going to have to use my answer from A. So it's going to be 0.5 times 4 times 15 squared. I can do that in my head. 15 squared is 225. 450 meters. Number 19, as I read the question, one of the first things I noticed is I better get a negative answer. If I don't, I've made a mistake. We're slowing down. So I said A equals VF minus VI over T, 15, no. 10 minus 15 all over 3.25. Bracket 10 minus 15, close bracket, divided by 3.25. And I got, is it negative 1.54?
Yeah.
Not a very big acceleration.
Still an acceleration.
Yep. But compare that with the motorcycle accident in question 20. So here, a motorcycle rider, a racer, collides with a haystack. They often use haystacks on motorcycle tracks to slow the riders down. So I think I'm going to use VF squared minus VI squared all over 2A. We are slowing down, so I'm expecting a negative answer, and I try and make up reasonable numbers. I'm going to guess you're going to get a fairly big acceleration. 2D? Sorry. This is why I defic and normally write stuff out. I think you get a fairly big acceleration. It's going to be 0 squared minus 42, because 42 meters per second, that's about 80 miles an hour. So that's about 140 kilometers per hour. To 5.7. 5.7 meters is about from me to Liam-ish. So you're coming to a stop fairly quick. 0 squared minus 42 squared divided by 2 times 5.7. Do you get negative 155? About 15 Gs. This rider, especially because they'd almost certainly be wearing padding and a helmet, probably survived, but probably had to go to a doctor or a hospital. Number 21. How fast was the jumper traveling? I think I'm going to go VF squared equals 2AD. Now, I'm making an assumption here that when people cliff jump, the VI is 0. I think you typically step off. You don't dive down. You might jump up a tiny bit, but I suspect that's pretty negligible. So VI is 0, square root. Oh, nice try, Mr. Dewick. Negative 58.8. What if I missed that, by the way? What if I went 2 times negative 9.8 times positive 58.8 and then hit the square root? I love the fact that you get a math error. In fact, my calculator says non-real. I like to think the universe is saying to me, dude, get real. You accelerated down and ended up above from where you started. I think not. So it will catch it. And that's one of the things, if you get a math error, check your signs. Okay? Square root. Why is 33.9 wrong?
Because it's not negative.
I have to insert the negative here.
You have to automatically assume you want the
Yep.
positive number.
Yep. Time. I think I'm going to use D equals AT squared over 2. You could use your answer from A if you felt confident that you'd gotten A right, but I'm going to get the T by itself here. I'm going to go T equals 2 times D over A square root. So it's going to be the square root of 2 times negative 58.8 all over negative 9.8. Square root of that. 2 times negative 58.8 divided by negative 9.8. Square root of 12, 3 point something. 3.46? Is that right? Okay, 2 marks for that. If the water took 3 meters to, what was the deceleration? Although I called it deceleration, hey, we're finding an acceleration. So I'm going to go with A equals VF squared minus VI squared all over 2D. Now, how did I come up with that? I said, well, they definitely want me to find A. Are we in the water in part C?
Yeah.
So A is not negative 9.8. Don't make that silly mistake because we're not in free fall.
That'd be silly.
I said VF was 0. Definitely D is 3.5. I need 3 things. What? I need something else.
Yeah.
Where's time? That's how long they're in free fall for. Is that how long they were in the water for? So I'm going to say, so don't take this wrong, but I'm going to say, bad guess. No, I can't use that. What did you say?
Initial velocity.
What's VI?
It is 0. Or, sorry, what?
I don't think so. My final velocity was,
3.9.
what?
3.9.
My initial velocity when coming to a stop in the water must be my final velocity of free fall. We've done that a couple of times before. There was the child slide question where one of our velocities final became an initial when we moved over. We've done that. I think we also did it in a car question or something. That might be fair game as an aha moment on your test. I don't know. So VI is negative 33.9. In fact, oh, I was hoping I still had it on my calculator. I don't. I was going to use my answer button. So it's going to be 0 squared minus negative 33.9 squared all over 2 times 3.5. You notice I put the negative in brackets because that's how I have to type it on my calculator. Or, wait a minute, am I squaring that negative?
Yes, you are.
It's going to vanish. I could type it like this, bracket 0 squared minus 33.9 squared, because putting a negative in the brackets inside the squared won't make a difference. This subtraction sign isn't going to vanish. Divided by bracket 2 times 3.5. Oh, 3.5, Mr. Duick. Is the water causing us to speed up or slow down?
Slow.
So I'm expecting a positive acceleration or negative acceleration. Well, it all depends, because if you decided to let down be negative always and up be positive, we are accelerating up because we're slowing down. If you did it that way, you'd get a positive answer. I didn't. I got a negative answer, negative 164. Okay. How many G's did the jumper experience while in free fall? That one's really easy. How many G's does anybody experience while they're in free fall? I don't know what that means. Oh, one? Yeah.
Yeah, you did the first one, right?
How do I convert an acceleration into G's? First of all, if I ask you how many G's, you're first going to find the acceleration, which I just did, and then? Yeah, why not? Why 9.8? Because that's 1 G for us here on the Earth. 16.8. If you left the negative in, I'm fine with that. If you didn't, I'm fine with that. 16.8 G's. I have a video of this, so put your pencils down, look up. Let's see how good our numbers are. Come on, computer, you can do it. So, you're going to see, and I'm going to convince you at the end of this, that this cliff jumper is not a happy camper. How many G's did he pull at the end in the water? Who remembers what I said where injury tends to start? How many G's roughly? It's around 10, okay? Now, 25 is usually you're not coming back from, so he's in the mid-range, but I'm pretty sure he dislocated his shoulder. Mr. Duick, how come it says 58,8? Because in Europe, they don't use a decimal, they use a comma. Really? Yes. Okay, how many meters per second is that? Something to do with the 3 points.
442.8.
It's not. How many meters? Is it times by 3.6 or divide by 3.6? Oh, it's divide by. What is it? What did we say V final was when they hit the water? What did we calculate it to be? We're pretty close. Okay. In fact, I suspect our numbers are better than theirs. I suspect they're adding a little bit of it to make it more impressive. But one thing I want you to notice on the landing, if you're cliff jumping, how do you want to hit the water?
Like a pencil.
Like a pencil. He's using his arms for balance in the air, and if you watch really close at impact, he hasn't got them quite tucked in. His elbows are still a tiny bit out. I think when he hit the water, his elbows got yanked up, and he either tore the cartilage in his rib cage or dislocated a shoulder. And I'll convince you of that in a second. So if you look, see his elbows are still pointing out a tiny, he didn't get them down. Oh, what did we say the time of flight was? 3.46, 3.58. Oh, air resistance played a little part, slowing him down. Okay, we're pretty close. You can even see there, he didn't have his arms tucked. That 3.5 meters, I watched this video a bunch of times. That's a best guess for how far down in the water he went, but I'm close. I kind of estimated a couple of body lengths. He's just set a world record. Watch his body language. Is he cheering? He's hurting. And even, he's kind of still on adrenaline. If you watch him get out, he's going to take one crawling step, and watch his body language here. So he straightens up. That step there. Oh, that hurt. That arm moving forward, that hurt. Get away from me. And then he's still not realizing that he's pretty badly hurt because he set a world record. What do you do when you set a world record? He starts to try and raise his arms above his head, and watch partway through. You can see this is not working well. It's a very feeble arms above your head. So he's, yeah, I set a world record. Yeah. Uh-oh, I can't go much higher than that right now. So based on all that, I think our numbers are pretty good. Okay? I would certainly consider number 21 fair game for your test, something like that. Those are questions I would expect you to handle, especially because, but I would include the phrase, assume VI is 0 or dropped or something like that. So I'm not collecting this quiz. This is your quiz to study from. This, because, oh, you got here late. Let me pause.